2.1 average and instantaneous rate of change. So if we recall, the rate of change is slope, which is y2 minus y1 over x2 minus x1, which is delta y over delta x, or the dependent per independent. The average rate of change on the interval a to b is represented by f of b minus f of a divided by b minus a. Average rate of change from a function. Find the average rate of change of f of x in the natural log of 3x over the interval 1 is less than or equal to x, which is less than or equal to 4. So to find this, we do f of 4 minus f of 1 over 4 minus 1, which is the natural log of 12 minus the natural log of 3, because you plug in 4 into the equation and then get 12 and 3 over 4 minus 1. This is 2.4849 minus 1.0986 over 3, which is 0.462. Average rate of change from a table. Find the average rate of change over the interval 2 is less than or equal to x, less than or equal to 30. So our f of x for x equals 30. So our y2 would be 7 minus our y1 is negative 2 over x2 minus x1. This is 9 over 28. Average rate of change. The following quotients express the average rate of change of a function over an interval. F of a plus h minus f of a over a plus h minus a, or f of x minus f of a over x minus a. This is also the slope of the secant line. Instantaneous rate of change. The following limits express the instantaneous rate of change of a function at x equals a. The limit as h approaches 0 of f of a plus h minus f of a over h, or the limit as x approaches a of f of x minus f of a over x minus a. This is also the slope of the tangent line at x equals a. Find the instantaneous rate of change of f of x equals x minus x squared at x equals negative 1. So the equation is a plus h equals negative 1 plus h, which is h minus 1. Then we plug it into this equation right here, and that'll give us h minus 1 minus h minus 1 squared minus 1 minus 1 minus negative 1 squared over h. This will become h minus 1 minus h squared minus 2h plus 1 minus negative 2 over h, and this equals h minus 1 minus h squared plus 2h minus 1 minus negative 2 h equals the limit as h approaches 0 of negative h squared plus 3h over h. Pull out the h's and cancel them out. Actually, let's pull out the h's first. H, negative h plus 3 over h, divided, equals negative h plus 3. You plug in the 0, and then this just equals 3. For the other equation, you just plug in the values. So x minus x squared minus negative 1 minus negative 1 squared over x minus negative 1 equals negative x squared plus x plus 2 over x plus 1, which equals, you could pull out the negative, factor out the negative, where x plus 1. Then you can factor this out, and it'll be negative x plus 1, x minus 2, where x plus 1. Cancel these, and this becomes negative x minus 2 equals, now you just plug in a, or the value of x, and then it's negative over negative 1 minus 2 equals 3. Identify the function we are working with. Then identify the x value for the instantaneous rate of change, slope of the tangent line at a point. The limit as h approaches 0 of 5 natural log 2 over 4 plus h minus 5 natural log 1/2 over h. The function f of x is 5 natural log 2 over x, and the instantaneous rate at x is 4. The limit as x approaches pi over 2 of sine of x minus 1 over x minus pi over 2. The function is sine of x, and the instantaneous rate at x equals pi over 2.